On n'a pas de retour par contre. Good morning, everyone. I'm very happy, really happy to be there today for this first day for EUNA, the association. On the introduction, I will give some information about this association created. It was in 2021 with 8 co-founders. And today we are almost 50 members. All of the members are really motivated by this really big advantage of the private mobile network, 4G and 5G, on what we can do with that, on what we can expand in the Europe area for that. First, just a reminder for some of you, it's founded in November 2021 with a few actors, as it was what I explained before. All of them were motivated by this private network and saw that the interest for the European industry about this subject. One observation about that, a few private frequencies in Europe in 2021, yes, but not in all of the countries. On those frequencies, sometimes different and unknown to the market. And it's really one of other subjects regarding this spectrum. If you don't have a spectrum, or if you have just a spectrum in one country in Europe, it's the same as to have nothing, because the ecosystem is not there and you are not able to deploy these networks. The objective of EUNA, for sure, is to promote the industries needs in terms of frequencies on private mobile networks, to expand again and again these networks in Europe and in the world also, gather and highlight the needs of suppliers, service providers, integrators, and above all, end users. It's why the members of in EUNA, there are a lot of different categories, suppliers, integrators, end users, consultancies, etc., etc. But all of the members are motivated by that. Yes, the subject is to harmonize the frequencies in Europe. To have the spectrum is good, but to harmonize it is better for the ecosystem again. Without that, it's not possible to start the Industry 5.0, because IoT and something like that regarding the Industry 5.0 is not possible without any ecosystem. If you have to, for example, if you have to buy 1,000 IoT for in your country and nothing else because it's not possible with your spectrum, it's the same as to have nothing. It's what we want for the European, and again, for the sovereignty of the Europe also, because we hear a lot of sovereignty in Europe, but without spectrum, nothing else. Yes, maybe you know this kind of subject, but a particularity of that is, in fact, in France, we were really happy to have a spectrum in 2019, thanks to the French regulators to obtain that, and it was really a first step for the private networks, I think. But it was for the 4G and really linked with the human connectivity, as you can see on the right. The observation was in fact in Germany, for example, but in the UK today and so in other countries, there was another band, the band 77, 78, and we see that the ecosystem is really growing with this band in the world also, not only in Europe but also in the world. It's why we think that it's really to connect the machines, all of the machines. I didn't explain, but sure, you have the robotic, you have the HGV, something like that. It's possible with the 5G. But today, we see the difference between, again, 4G and 5G. The observation also was, in fact, the ecosystem regarding the connectivity for the human human devices in 5G is not really there, was not really there, but today it's coming, sure, with the band 77, 78. Another, I forgot one subject is the band 450. It's another subject that we had with EWINA. It could be with on the right, and to be honest, it's a really interesting subject regarding the spectrum to change the tetra system, for example, when you have a large coverage, you need a large coverage. This spectrum is also an interesting spectrum for Europe. But as you can see, too many European countries are without private spectrum, or really alone. It's really for me difficulties. And in the end, I hope it could be quickly. I hope also, in the end, if we can have a 5G private network for all of the activities, human, machines, everything with the same spectrum, it's really, again, interesting for the industry, European industry 4.0 and 5.0 also, to extend this subject and to extend the how can I say, the efficiency of the European industry. It's really what I want with EWINA, and it's really where we want to go with all of the members of EWINA. More and more countries, more devices. It's really what we want for the European area. On infrastructure also, providers, especially for IoT, it's interesting. On more response regarding the service to European industrial needs, because we see also the difficulties regarding the private networks is the number of the components that we can have. And if we have a good service to propose to the end users, and you will see that in this day, it's again better and better at the end for the industry 4.0 and the European industries. Better ROI, better ecosystem, and faster European digitalization and industry efficiency. The members, today we are not 8, we are almost 50 members, and you can see a lot of different origins. Corporate users, unfortunately today we have just two, Schiphol Airport and EDF, and it's really where we want to increase the number of corporate users, because the subject is for you, the users, to increase again the ecosystem. We have some association, Agur, I know really well Agur, but also BTG on another association. We have the consultancy, a lot of consultancies are coming, they are really interested also with this private network. On test and innovation is really a subject. I think that there is a panel regarding this subject, and it's really what we want to increase also is the service, because different components, it's interesting to have really a good system to test, to make the monitoring regarding this system. We have also the SNIR also. We have on some a lot of other members, suppliers, service providers, integrators. You can see the number today after three years. Again, interested to increase the market and increase this subject, and to harmonize the spectrum for the European area. Action, because sure, we are an association, we have to work on it, on the private networks. There was an appointment of a vice president representing end users. Thanks, Petra Classen, sorry, for the president of BTG. She is coming as a vice president, and she wants to represent. She is representing all of the end users, the use cases and something like that, to the regulators and to other entities. We are at the CCW Partner Village participation in Helsinki, but also in Dubai, and it's for the TCCA. We are there to enlarge the perimeter of the TCCA, to don't be just for the PPDR, but also for the industry. It's one of interest subject for EWINA also, to increase in different events the interest of the industry regarding this subject of private networks, private and critical mobile networks. An arena appointed 3GPP SA1. It's with Thierry Berizot, one of our board members, and we are representing the end users at the release 19 regarding the interconnection of private networks. It will be a subject in my panel. You will see that it will be the panel 3. And we will explain that. A creation of the main ports entity, because we saw with Conmulet that these kind of subjects are not really well represented in different entities. It's not the same with the railway and the energy, and it's where we want to increase a community and to exchange and to share the use cases in these entities. A webinar on main port, also subject on energy. It's what we organize. Thanks the Port of Rotterdam and Petra Classen on Antoine van der Sijt to organize this subject, a visit of Port of Rotterdam. Interesting subject also. We made also a creation of the frequency repository. It's another subject interesting, I think, for all of you. It's to show the panel of the spectrum that we are able to use in Europe. Sometimes nothing, and we are really increasing this repository because we don't have all of the countries today, all of the European countries today in this repository is really where we want to progress. Is to show all of the map regarding this spectrum, what we can do in different countries in Europe. We made also some response to represent the industry on the end users regarding some demand like the RSPG, for example, but also some other regulator consultation. It's a arena to answer, to say, okay, we need this spectrum because it's to do that for these verticals. It's where we are also on where we want to progress also and to be in all of the consultants in all of the consultation in Europe. The repository of the spectrum, it's yes, you can see that on our website. It's really where we make some updates. It's arena.eu, and you will be able to check on to see the different context of the spectrum in Europe. As you can see, we have a lot of countries we don't have on the map, and we have to complete that. But it's really where we are working today in waiting for the harmonization. At minimum, it's to show what we can do in this different spectrum, on these different countries, sorry. And it's really where we are working today. And to show again, like EDF, I don't know, like some other Total, for example, if they want to deploy one factory in one country, it's interesting for them to see, yes, we can have a private network. No, we don't have any spectrum. It's not possible for us. It's really a first step for us, for you, the user. It's finished regarding the arena presentation. On just for you to see the agenda. It's 6 panel. For me, it's really where I wanted to make an update regarding these private networks. It's where we are. I think that some of you knows. I hope that some of you know the private mobile network since 2019 for the French guys. I think that I hope that you know that. And it's really what I wanted to do, it's to show the different subjects on where we are with these different subjects regarding the spectrum. It's first. Second, it's regarding the technology, where we are with the technology, 4G, 5G, what we can do with that, with the core, with the RAN. It's a second panel. The third panel, it's with myself. It's regarding the subject of the private network and public network, the coverage, what we can do today, because I heard sometimes some industries that, well, we have private, but we want also to have some usage with the public network. It's one of the subjects that we will see that in this panel. And in the afternoon, you can see 3 other panels regarding the complexity of the monitoring and ensuring service. I think it's really important today to show that we have some ability to monitor these networks for the industry. On the second in the afternoon, it's the use cases in main port logistics on healthcare, but on the last one, it will be the use case in energy, mining, and factories. Again, to show some use cases, but sure, I hope in the end, it will be for you more clear, I hope. on it's really what we wanted to do with this new event of EUINA. Thank you very much, and I hope that it will be a good day for you. Have a nice and interesting day. Thank you.
Hello, everybody. I'm Thomas Hervieux. I'm a member of the UENA Association, and I'm very happy today to moderate this first conference of this first UENA event that I hoped will be the first of many others, a very popular event. We will be speaking today of frequencies, which is one of the main topic of course, private mobile networks. It's an enabler, it's a prerequisite, if I can say it like that. And along with me, I will have many experts of the industry, of course, and we will have a deep dive on this subject. So first of all, I will introduce you the member of my panel here that are present in the studio with me. I will start on my extreme left, which is Didier Chauveau, who is the Deputy Director Spectrum Planning and International Affairs of ANFR. ANFR, which is l'Agence Nationale des Fréquences. It's a French agency managing the frequencies. I also have Gösta Kallner, who's the Executive Chairman of the Alliance 450. I also have Vincent Audebert, who is the IoT and telecom expert at EDF, the French utility electricity company, producing company. And remotely, I also have Abel Mayal from the company Airspan, the manufacturer Airspan, who is the SVP in technology and marketing amongst this company. So I'm very happy to have you with me today. So I'm going to direct the first question to you, Abel, who is remote. First of all, for the audience, can you explain why spectrum is so important when we speak of private mobile radio?
Thank you, Thomas. I love this question, being the radio guy in the panel. You have to think of a spectrum as the oxygen of the wireless world, right? Like human beings cannot live without oxygen. The same for wireless technology. It cannot operate without spectrum. Spectrum is a finite and highly valuable resource that enable everything that you connect with. Like, for example, right now you're connected with your mobile phone on a 5G or 4G network, your laptop with the Wi-Fi, your headsets with Bluetooth, and even satellite communications, right? So everything depends on the spectrum. When we look at 4G, 5G cellular networks, spectrum plays a critical role for both factors. One is coverage, the other one is capacity. So when you look at private networks, it's very interesting to assign the right spectrum. For example, when you look at utilities, smart grids, these are private networks that need like massive coverage, normally nationwide, and they have to go very deep because some of the meters are underground. So you want to use a spectrum that is in the low bands. For example, sub 1 gigahertz. One beautiful spectrum is 450 megahertz. We have our colleague Gösta that will talk more about it. And that provides a very deep coverage. But on the other side, you have lower capacity. That means that your speeds are not very high. If you go to a warehouse where you have a lot of machines, robots moving around, cameras, you need like high capacity, higher speeds, so gigabits per second. But the coverage in these high frequencies is going to be less. So that means that you are more limited in time of the distance that you can cover. From the economic standpoint, a spectrum also is a key asset controlled by governments. Normally, a spectrum was given to mobile operators, and they pay, billions of dollars to get a loan of this spectrum. But there was a change with 5G because 5G is the first generation who brings real features for the industry. And then private networks were very interesting to start using these 5G networks. So some governments, they were fast enough to start providing a spectrum dedicated for these industries. And there are countries like the UK, Germany, the US, Japan, they have done so. And if we look at Airspan, from our experience, we have deployed around 500 private networks. And my guess is around 95%, they are deployed in countries with these dedicated frequencies. And these create more competitiveness in these countries, because imagine a warehouse in a country where they can have this 5G network and make more efficient their operations compared to a country they don't have this dedicated frequency and they have to go through MNOs and more hurdles in order to get these.
It's interesting what you just said, Abel. Can you explain just really briefly that you can get some private spectrum, but you could, in some cases, you could also get it delegated from MNOs. Is that what you're saying?
Yes, correct. So MNOs, they always have the spectrum, right? So all the mobile phones that we have, they work with MNOs, with public networks like Orange, Telefonica, Vodafone. So they are the owners of the main spectrum. In some cases, what you can do is like you can go to these MNO and ask them that you want to do a private network inside your company. And now with 5G, they can create like a network, like a network slice for your company to have this private network. But what we see is that going through an MNO could be, depending on the MNO, could take longer, right? And maybe more expensive, so it's not attractive. But in other countries, and for example, I will put the example of the UK. We have a big office in the UK, and we applied for a spectrum, 100 megahertz in sub-6, 3.6. It took us like 3 weeks to get it, and we pay like $1,000 a year for this spectrum. So it's very, very affordable. It's very cheap, and you have, a magnificent spectrum bandwidth to run your private network.
Yeah, so I see that you understand that despite having some possibilities to get spectrum from MNOs, the simplest ways is the most efficient seems to be the access directly to the government bodies. I'm turning myself to you, Vincent. What's the policy, for example, for a company like EDF, which is a strong utilities regarding spectrum? How do you manage that amongst a company like EDF?
So we are currently not only using private telecommunication, but MNOs communication. So it's very important for EDF. It's a very large company to use all the telecommunication means we can get. And we are very pushy in trying to have the very good relation with MNOs and also to have the best of what we can obtain with the spectrum. So it's not only a frequency, but it's the way you're going to use the frequency. So currently we are lucky in France, and thanks to things that we have done with Azure, we have the 2.6 spectrum that we can use for private network. So we started quite early with Christian also from Air France to deploy our network in the private for the private network in nuclear power plant.
You had a tradition in narrowband. You started out.
Yeah.
So it was.
Yeah, we were it's an evolution, of course, but as I say, why we need MNO, why we need a private network? It's just because we're going to more digitalization. So as all the big users, we are on digitalization trend. So we need to have the right solution for the right problem. And when you are managing digitalization inside a nuclear power plant, well, you want to be able to manage your solution. So that's why you need this private spectrum. Currently, this is very important for us. You will not give to another tier the fact that manage the solution. So this is how we are currently balancing between MNO and private things. Ongoing project in nuclear power plant, wind power plant, thermal power plant using private spectrum.
What is the criteria between choosing private spectrum towards MNO's solution? Is there how do you evaluate that amongst EDF?
So it depends of the need you got. So if you are currently and something that is very crucial for you, critical, I would say. It's important that you can manage everything. So in this case, you want to be able to work on your own, even in case of crisis. So this is why you want to have your own infrastructure. So you need this spectrum. But if you have some more on digitalization for a day-to-day basis, it could be a solution that you are using MNOs. And we are not speaking also with new things that could happen with satellites and so. So that's what is nice in the telecom era. There's so many things that can help big companies or even smaller to move in the digitalization pathway.
Thank you, Vincent. So I'm turning towards you, Gosta. I think Abel just mentioned it a bit. Some spectrums have different properties depending on the frequencies, of course. What is the how would you map the use and the frequency? Is there can you explain to the audience how frequencies can be ranked in terms of use?
Yeah, I think it varies a lot. Especially, we usually start looking at the use case to see what spectrum are actually a good fit. So when we work a lot with the lower spectrums, that's typically for nationwide networks, for utilities, for railways, for roads, for public safety. But you have not everybody had that demand. Some are very local. Some are just evolving, as you say, on narrowband systems that all of a sudden need more bandwidth. Quite often, just a logistics center that previously just have intercom radio connectivity now want to have automated robots running around. It puts a completely different demand, and that's what we've seen. We have today, at least in most parts of the world, narrowband or broadband spectrum now in the lower bands that are used privately, even as legacy as PMR and so on. We promote then, of course, the 4G, 5G in these bands as well. Then we have the mid bands, which is, I would say 3.5 is probably the dominant, even though we have here in France and a couple of other places also, I would say 2.6 and 2.3. And then you have the higher bands. And it's more local you go.
What do we do with the higher bands? We spoke a lot about the higher bands recently. It was one of the band of the 5G. Is there something, are there any use cases? Do you see anything as a trend in the world?
I think usually what we see, and I would say that's probably a band migration, where people today using low bands for narrowband solutions, typically in the 450 or the 410, don't really need it because it's just local, maybe even for a shop. They can go in a much higher band because they just need a coverage for that. And usually they want to increase the amount of bandwidth. So that's also an evolution of moving people to the right spectrum for the right services from the existing, because things evolves. And I would also say that many of these ones also have the tendency to evolve to have their own control. I think that's maybe one of the most important thing is when you look at commercial spectrum and commercial operators today, they evolve not with EDF or with the industry. They evolve what they think is good, not what the user think is good. The main users, but not maybe all. And that's also the importance of having your own spectrum, is to control the life cycle, maintain your own service, and on your goals or what you require, you can upgrade and change technology in the spectrum, and therefore also in some cases change spectrum, depending on that your service have changed.
Thanks. Interestingly enough, this trend, because it's a working discussions we also have at Agure, is to try to tell people who use low bands that even though it's because it was the narrowband legacy band, maybe that regarding their coverage zone, it's not necessary, and they could shift to higher bands. It's something we realized, and we're trying to also promote to free these lower bands that are much more useful for broad coverage. And I think it's something we didn't reflect earlier on, but now it's becoming clear that we need to use the bands for their right properties. And so I'm turning myself towards you, Didier. Can you tell us on I would say on a regulatory approach or basis what work have been done in the last years, in the past years, regarding private spectrum access?
Thank you, Thomas, and a lot. But just a few words about ANFR, and thank you to Wena for inviting us to speak today. ANFR is, as it has been said by one colleague, is taking care about strategic national assets, which is the spectrum. And in particular, we are engaged on the long-term spectrum planning on behalf of various interests. in France, Ministry of Defense, Meteo, radio astronomy, and also commercial 5G for ARCEP, and also broadcasting for ARCOM. I think just to respond to your question, we are engaged on around 60 various entities addressing spectrum at international and European level. This is a lot. Just recent updates, maybe you heard that in spectrum management, we have particular, I will say it in French, rendezvous, which is the WRC, World Radio Spectrum Conference, updating the radio regulation, which is the first pillar, the first legal basis in spectrum, which is an international treaty. And the last update of the radio regulation has been done last year in December in Dubai. I noted that maybe you attended also, a number of you, this event. And one particular result has been to identify a new frequency band for IMT in a 6 GHz band, 6425, 7125 GHz, and which is triggering some activity in Europe. At EU level, we have recent updates. I heard about millimeter wave bands. We have harmonized 42 gigahertz at European level. It is available and harmonized, and we have the 26 gigahertz, which is harmonized since 2019, 2020. And I assume it's a great opportunity also for vertical private usage, and I assume you will discuss that today, how to be engaged also and to use this resource. On IoT, I noted that interest on IoT. We updated the 900, 1800 MHz band at EU level 2 years ago in order to offer the possibility to use 5G and also IoT system in this frequency band. We have the 2.6 GHz, which has been updated for 5G a few years ago. We have also we updated the framework for Wi-Fi, new resources for Wi-Fi at 5 GHz, and also at lower 6 GHz. So this is recent updates from our side. I could develop if you like.
Well, yeah, thanks a lot. It's very wide, and it's very interesting to see all these works. So I heard you saying a very important word in your exposé. Was harmonization. This is why you're working at the international level is to get some harmonization. So I'm going to turn myself to Abel. Why is it so important, harmonization? Why do we want to work on these scheme? What are the impacts and what is the importance of that?
Okay, the spectrum harmonization, as you said, is vital for the global telecom ecosystem. First, it makes our life so much easier, and explain why. Think of harmonization as a common language for the technology, right? So you can ensure that devices, networks, and industries can communicate seamlessly. When the spectrum is harmonized, it drives a faster ecosystem, right? Because we can focus on the innovation rather than creating different types of radios or products for different regions. Also, cross-border operations. We saw that at the beginning of mobile phones, right? FSG, 2G, even 3G. And depending on the country you travel, you have to change your mobile phone because they had different frequencies that your mobile phone couldn't support. Nowadays, with 4G and 5G, this doesn't happen anymore. You can travel around the world with the same phone, and you can use it anywhere. Imagine this now with private networks, right? There are many companies that are global, and they produce products like us, radios, that they are related with the 4G and 5G networks. So if there is no harmonization, it means that you have to have a stock of different chips, radios, and equipment, right? Depending on the country that you're shipping to. And for example, when you look at S-band, and we look at the 5G private networks ecosystem, if we look at 3 main regions, the US has CBRS, that is 3.55 gigahertz. Europe is between 3.7 gigahertz to 4.2 gigahertz, and then we move to Japan. Japan has a higher frequencies, 4.6 to 4.9. This is all for private networks. So at this point, we can cover all these three different regions with two what we call SKUs, stock keeping units, so two variants of the same product, up to three variants, and that makes our life much more simple. Imagine that each of these countries, right, they have their own frequency. You have to have a variant for each of them. So that what creates is that we can really focus on what matters most, that is the innovation that we can bring, the new features, instead of having logistics headaches and operations headaches, because trying to follow what each country is doing. Another important thing about regulations, and this is something that follows the introduction that we had at the beginning of the event, is the role that regulators plays in the use of the spectrum. And I'm going to make a very simple example that we are seeing a lot. Imagine two countries. You have a warehouse in the middle of nowhere, and we have two countries, one in the US and one in Europe. For example, let's select Germany, that they have also dedicated the spectrum. They build their private 5G. Basically because they have many machines or robots moving around boxes. They have also outdoor coverage, so there are things that 5G works better than Wi-Fi. We love Wi-Fi, but we think that 5G can complement very well 5G. So for this use case, a 5G private network will work quite nicely with this dedicated spectrum that we get in US and Germany. So they build their same warehouses. After a few months, they realize that their coverage on public networks, so to make normal phone calls, is very bad because they're in the middle of nowhere. So they have the typical struggle to go to a point in the company to make the phone call, right? And they say, well, now we have a private network with a beautiful coverage. Why not can we have a public network on top of that, right? And this is something that it was mentioned at the beginning. And in the US, if you talk with a regulator, they say, yes, of course. In your CBRS spectrum, what you can do is you can piggyback the MNOs. T-Mobile, Verizon, AT&T, you can transmit it in the CBRS frequency. So using the already existing infrastructure, you get private and on top public network to make your normal phone calls, which is great. But now you go to Germany, and this will happen in the UK or other places in Japan. You go to the regulator and say, I want to have a public network now. Say, oh yes, you can do it, but you have to use the frequency of the MNO. So that means that you have to have new equipment that supports the frequency of each of the MNOs. So that means that you can have up to 2 or 3 radios extra to provide this public network coverage. So when you look at the same use case, the competitiveness of having regulator allowing to use the same frequency used for the private for the public make this use case much more attractive in other countries. And we see that US is one of the countries that is thriving about indoor coverage. Think about hospitals and hospitals.
So what you're saying is, I think it's important. It's a very important key message, is that for companies that are multinational, that are implemented in various countries, the harmonization allows to implement same product lines, same policies, same architecture. And that is important for them in planning their investments, and especially in IT. Am I summarizing what you just said in terms of
that's correct. A very simple example. You're doing a meal for your family, right? You can create one meal for your 2 kids and your wife. Or for example, your wife doesn't like pepper, your kid doesn't like onion. You have to do 4 meals for each of them, right? So at the end, the logistics of that is more cumbersome, right? You have to have a stock, you have to have logistics, so it makes it much more complex. So the important thing for us is to focus on innovation, right? When you have a variant, like a model of a radio, we can focus on the features that we bring on top of that, instead of working on, we have to change this filter, this amplifier, because this is going to be shipped in this country, right? And now we have to change this and test it again, because we ship it to another country. So the whole operations and logistics is much harder when you don't have this harmonization. So that slows the ecosystem. With a good harmonization, the ecosystem thrives.
No, very interesting, very important point. I think it was the analogy with the meal, the anniversary meal birthday meal is quite relevant. Regarding Gosta, you are in you have the difficult task of trying to harmonize the 400 megahertz band, which is a legacy band for PMR, which is very important. We discuss a lot amongst Agur. Can you tell us what's going on there? What are the works, and what are your challenges?
I mean, I think when you come to the lower spectrums, a little bit what Abel said as well with regard to harmonization, reusing, and so on in different locations. Here you actually have borders that goes across. So we have coordination not just within the country of legacy users, or if there are legacy users, sometimes it's an in-band migration from a current operator that just upgrades from what they, or doing a generation upgrade of their systems. But it's also the cross-border of making sure that we have not a different, or preferably not different system in different countries, because they behave differently. And we have different regulations also in different countries around the world on how they prioritize bands within the border. Typically, I would say actually in between Germany and Netherlands, where they have prioritized part of the 400 megahertz bands to be able to go quite far into the country from Austria or from Germany to the Netherlands, and the opposite on part of it. So they have kind of a spectrum coordination. When you're all of a sudden using the full band at the border, then you get a different coordination than you have had previously, and then you both countries need to harmonize the spectrum, preferably at the same time. It simplifies things. And I think that's also what we will see in many of the other spectrums going forward, because they have had other use. I think in the 3.5 we have had quite a lot of WiMAX in certain countries or in certain regions. We have other things that we need to coordinate and harmonize and work on the migration process in this, and quite often coexistence, to actually make sure that they work together and that we refarm a little bit. It might be that what we do mainly in the lower bands is that we try to make it more spectrum efficient, because the amount of user usually lowers with a new technology in the band, because they're usually the same users that are using the new band or the new technology as the legacy technology. And that kind of ties into that you might start with lower bandwidths and then gradually grow. And that will, I think we'll see in many of the bands. We had that in the 3.5 in certain areas as well, where people started with very low bandwidths because it was occupied by others, and then gradually they evacuated those bands and moved over to the new technology. We have exactly the same here, and I think also pending a little bit if it's a broadband function or if we're looking more at narrowband.
So regarding, if we focus really on the 400, you consider there will be coexistence between narrowband and broadband? Will there be, in the end, space for two?
It's in most countries. We worked with the 450 megahertz already on NMT, on the analog first systems. That was already occupying 4.5 megahertz and coexisting with PMR, with meshed system, with a lot of different systems in most countries. Then with the analog system moving out, then it was a little bit more of an interest in the PMR band, so they took more spectrum. Now we see, I would say, a decrease in that, because people, especially typically taxi, not many taxis today have a PMR radio, which was one of the biggest use cases in 450, also road assistance. They use the commercial networks, they have an iPad where they instantly don't have to argue who was calling in to take the ride first, right? So it's a different, technology evolves, and therefore I think it's natural to have these coexistence. But sometimes one will be larger than the next one. So the coexistence definitely is there. There is not, I would say, a kilohertz not used in these bands today, especially not in Europe.
And the implementation of broadband in 400, how is it going? Is the outlook, is it progressing? How do you see it?
Yeah, I mean, for us, you more people want to connect things, you more data people want, you more you need this. And I think it's from a private network point of view, the industries that are building this, we have everything from oil and gas, with Aramco was the last one that actually was awarded a license in Saudi Arabia, to utilities in Europe, I would say mainly, also in Latin America, mainly utilities and quite a lot of public safety users. Sorry, if we looking at Africa and part of Asia, we also have it for railways, where they don't use MCS, but they use 450 instead. So we see these services going all over the place, but I think also the difference and what we complement with in many cases, especially in the 3.5, is that we can do the narrowband IoT and the LTM kind of low power, low bandwidth solutions to complement other things. So
yeah, it's clearly an IoT solution, the low band. Didier, I'm coming back to towards you. What are the trends? What is you just spoke of the past? Can you just tell us what's ahead in terms of normalization? There's one very important question that I think I really need to ask: is the 3.8, 4.2? When will it be available?
Yes, thank you for this question. So I will focus on spectrum harmonization, and in this area is asking a long-term effort, and this has been explained by colleagues before about the complexities in the spectrum environment. We are facing from ANFR side to a lot of demands, and we have a strategic resource to manage. Just for the few words about the 450 megahertz, which is a strategic band, as I heard from your side, and as you are aware, there is a well-established voluntary harmonization framework in Europe, thanks to CPT, and you have the framework in place in order to respond to a particular demand. For example, if you like to implement 3 megahertz bandwidth standardized by 3GPP. The main issue is at national level. How to reorganize the spectrum, taking into account that you have different users in this frequency band. And this has been, so the European Commission has done a consultation from member states at the beginning of this year. Is it possible to move on and to have an EU harmonization, a mandatory harmonization for private network in 450? And the feedback from member states is not yet, it's too complex, too various usage. So we have to address the topic on the basis of the voluntary harmonization from CPT at national level first, and thanks in France to ARCEP. I'm aware they have done a public consultation on this 400 megahertz spectrum, and we are waiting for feedback from ARCEP, which is taking care about private networks. But in this frequency band 450 in France, for example, you have defense and home office, which are using the spectrum. Just coming back to one topic on which we are engaged since a number of years, because when we are addressing spectrum harmonization, we are counting on years, sometimes on decades. And we are engaged on 3.8, 4.2 gigahertz harmonization for vertical, for private networks. And ANFR is investing a lot. And we are expecting voluntary harmonization very soon and EU harmonization next year. So you will have a great opportunity in order to roll out private networks in 3.8, 4.2 gigahertz. But there is never free lunch in spectrum. You need to coexist with Earth Station. In France in particular, or with fixed service in other countries in Europe. You will need to protect commercial networks at 3.8 gigahertz. And also you need to protect radio altimeter, because you are not so far from the band which is used by aeronautical radio altimeter system, above 4.2 gigahertz.
What does it mean to protect?
To protect, so that means that you have to avoid, to create interference to mobile networks, for example. So that means there is a price to pay, because the debate that we had when we developed the spectrum harmonization in this frequency band, the debate that we had is, do we offer the opportunity to reuse equipment standardized according to 3GPP specification? Or are we introducing constraints to this 3GPP specification in order to protect adjacent users, for example, mobile networks. The feedback that you receive is prefer to keep 3GPP specification with no change. So this is what we have decided.
So the responsibility gets back to the regulator.
Yeah. But the price to pay is to coordinate on case by case when you will roll out private network in 3.8 4.2 gigahertz. The price to pay is to coordinate on case by case, if needed, with mobile networks below 3.8 gigahertz. So from my NFR side, we submitted the trade-off, either harmonized constraints in order to protect 3.8 or mobile networks below 3.8 gigahertz, or reusing same equipment, 3GPP specification without no change. So the feedback that we receive, we prefer to reuse 3GPP specification, but the price to pay is to coordinate on case by case. But I think this is a great opportunity for private networks in Europe. You will have 400 megahertz dedicated for this type of usage. It's a great opportunity.
This is a strong message, and it will come and it will be large. So we will have the possibility to play with that spectrum. So now I'm turning back towards Vincent. Well, are you happy with that, Vincent? Do you think that following all that was said?
We are always happy from the regulator, but we say maybe we can have something slightly different. So we are very happy. We have the 2.6 long term, but as it has been said by everybody on this discussion, we need to be harmonized, so standard and equipment. 2.6 maybe is not the main focus to build equipment in 5G. So it was very important for us to move to something that is at the level of Europe at least. And that's why EDF is a member of WINA, because we want to have something that is shared with at least the European countries. So what is happening in 3.8 and 4.0, that's nice. Now we can move, we think, to 4.2. That's fantastic. But you have to see the small line that has been explained.
So the constraints, what was...
Yeah, so low power or medium power. So if you have a huge campus, it won't be so easy. And especially there is multiple place in France, or maybe we think it won't be allowed. So this is a real problem. And this is what we can see from the last consultation for ARCEP. Well, there was another solution to add with this spectrum the lowest band of the 3.4. This is a spectrum where you can have high power UE and high power relays. So it is important. It could be important if you have a huge campus to access to this spectrum, but it seems that currently ARCEP is thinking it will be better for MNOs. So this is a discussion, important discussion. I think all the people that are listening to this panel are able to send their voice to the regulator, and it will be possible for them to explain what are the needs of the domain. So yeah, we are very happy. We see that things are going on also on the 450. So we have a real discussion inside France. There is an harmonization that came from UE, but well.
Yeah, I think it's important. Yeah, in terms of constraints, it's this is something we mentioned. I think I discussed a lot with Vincent. Power is important in 5G because we need to have power to get modulation, and modulation will give you throughput. And it's important. We'll see how the translation comes off, but limitations in power will have consequences in the implementation. And I think what one of the demand of the users, but I'll leave you to confirm that, Vincent, is that we need to reevaluate these constraints because we understand that we want to be prudent. But if we realize that we can do a bit more, I think it will be very much appreciated if we can see that these barriers become removed, or at least loosened in time. I think, is it something?
Yeah, it's also important in our business. So 10 years is not a problem for utility. We are working 10, 20, 50, so it's not a problem. We are able to work for a long time and to be patient. but we need to, when we move to a solution, we need to be sure that this solution, that is more or less a 3GPP solution, so that was designed especially at the beginning for a user using smartphone for CATS video, could last very long for a professional user. So very important to be all together and to be sure that the solution will be applicable at the right
time
for a long time, and that we can use not so many base stations to have the right coverage in certain area.
Did you want to add something just before we move on to the Q&As?
Just to say, we are facing to the same speech from various stakeholders. So each day at NFR, spectrum users are knocking our doors. We would like to access to this spectrum. So sharing is now our top priority, and we are opening. We will open the 3.8 for the 2 GHz on harmonized at EU level, and this is a strategic asset. But I think there is a price to pay to use this band, because you have to have in mind that this 3.8 for the 2 GHz is the only band which we made remain for satellite usage in C-band. So this is also, from the other side, a key asset for them. So the price to pay is to share the band and to have also long-term planning, taking into account various opportunities and various ranges of spectrum to address your need.
Thanks, Didier. It's very interesting to see that the difficulty from regulator to try to fulfill all these demands. Well, thanks a lot for this great discussion. I think we have a few questions that we can take from the audience. I have one right here. I'm going to read it out loud. So it's from Rudy Alex. He says, you mentioned that most companies are still relying on Wi-Fi for their private local network. How does a private network complement an existing Wi-Fi network or even replace it? What are the pros and cons of both Wi-Fi and 5G private networks? I think I'm going to direct that to Vincent, who's a user. Can you explain a bit the positioning between Wi-Fi and private network? What's your take on that?
Well, currently, it will be very short. In your nuclear power plant, we have made some tests with Wi-Fi, but it was better to go to LTE.
To what?
To go to LTE 4G. So we are deploying 4G.
But why? Can you just say why better? Just.
But you know, the Wi-Fi has been done.
I have my view too, but okay. I prefer you.
Yeah, that Wi-Fi has been done more for static user. The amount of energy you can use to communicate is less than in 4G. And of course, there is a huge band, but it's not really what we need in critical communication. We need, on the other, we need coverage, we need security with the SIM card, so all these things. So that's why we are currently working with 3GPP solution.
That's a clear response. I'm reading another question. Carlos Pedras Rodriguez. So he asks, public MNOs rely on 3GPP RAN 5 test specs and certification programs by Industry Alliance, GCF-PTCRB, for guarantee global interoperability and roaming of devices in different bands. Would you expect the same approach in public networks or in-house project-based testing? Who wants to take that one?
I can take that, since we are partners with GCF and works a lot with them. I would say that yes. Very simple answer. We are, of course, trying to. The GCF is the global certification forum. We try to get all the tech specs and everything run through that organization with all devices and equipments to support 3GPP and guarantee quality.
I would like to come back to the previous question, the first one, about Wi-Fi for private networks. From French side, we push for work and development of work item in CPT for investigating, for having the possibility to investigate the usage of Wi-Fi with 4 watt high power Wi-Fi in the lower 6 GHz band. So we identified that possibility as a great opportunity for private networks. We launched a work item in CPT a few years ago. I wonder if colleagues from Wi-Fi side are attending this event. But please contribute to CPT, because the work item has no progress since number of years. So Wi-Fi forward in lower 6 GHz. This is a great opportunity for private usage, but no contribution, no input, nothing happened. So we are ready to work on that. We have in mind the database approach to manage the access to spectrum, like CBRS in US.
Then it becomes private spectrum.
But I think this is Wi-Fi usage forward with high power, suitable for private usage. It's remain Wi-Fi band unlicensed, so you have some strengths and weakness, but it is up to you to assess if this is useful or not. But I think this is an opportunity for usage.
Which band exactly is that?
This is a lower 6 GHz, below 6425 MHz. You have a work item. 6425 MHz.
That's.
But this is the lower 6G. That is the private Wi-Fi. But I could I will provide.
That's quite high for
I will provide the detail. I will provide the detail.
Yeah, do you want to add something on both of the questions, Abel, perhaps on this last question?
Yes. On the Wi-Fi one, we have this question a lot, and what we say is that Wi-Fi is great for certain use cases. Everything, I think Vincent was mentioning this, everything is static, right? Connecting your laptop or connecting a camera, for example, in a building is fine. But when you go with things, certain features, mobility, for example, everything mobility-related Wi-Fi is not designed for that. Basically, it doesn't have a core network that controls a radius, right? So anything mobility-related. Cellular networks are better. Security, you have a SIM card that is encrypted, creates more security. But also in certain use cases, outdoor, the coverage you get outdoor is better in 4G, 5G. Interference cancellation also. When you look at airports, right? It's indoor communications inside airports. Everyone has Wi-Fi hotspots. There is a big interference there. You cannot rely on critical communications on a Wi-Fi network, so congested. So you need to have a private network using a dedicated spectrum for using cellular technology. So Wi-Fi is great for many use cases. And as I said, you can complement it with a 5G network. And this is what we are seeing in our experience. We focus on the use cases where we see value on a private network. If Wi-Fi can do the job, fine. We don't go there. We go to the use cases where we see value on the 5G and can solve a problem.
Yeah, interesting point. Thanks a lot. We don't have any, I think, more questions. But is there anything you want to add? Yeah, Didier, you want to say something?
Yes, just to share a few words on 6G, because on spectrum we are taking care about long-term spanning. So maybe this is the fuel for SOCs during the day. From spectrum management side, and in particular from spectrum policy, RSPG, Radio Spectrum Policy Group, we are engaged on 6G, and we will, I hope, submit to public consultation a new report on 6G, also addressing verticals. So please contribute again to this public consultation. It has been mentioned.
What is the main? I think it's 7.5 gigahertz, something demand that is so far.
No. I think we are taking care about 6G as a whole, the sixth generation of mobile. And we are addressing various components, and including verticals. So you have the commercial and you have the verticals. And some are saying that maybe the vertical will be the first to engage on 6G. But I think we will 6G in Europe and in a number of countries now is as a target 2030 at the beginning of next decade. But from spectrum management side, we need to prepare the future, and please contribute to the public consultation from RSPG. It will be launched, I hope, in November.
Interesting point. So we're already now speaking of 6G, so we'll have to jump on this and see how it will impact private networks. I hope for good. So anyway, thanks a lot. I think we're running out of time. We're at the end of this panel. I think it was a very rich discussion. Thanks, Abel, from you remotely, and thanks for my panel in presence. We'll leave you for a short break, 15 minutes breaks. Then we will resume with another panel. I think we will have. There's a questionnaire, satisfaction questionnaire that will be sent. Please fill and give me the best marks because it's my panel. So anyway, see you later, and thanks a lot for attending this audience. Bye.
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 Yeah. Good morning, everybody. Welcome back. Hope you enjoyed the first session this morning. We're now moving into our second session, which already gone on, which is a technology session. So we will be sharing the thoughts of a number of our members who are involved in developing the core technology for private networks. My name is Peter Clemens. I'm a founder and board member here at UINA. I'm also the president of a French consulting company, Quixoticity EU, and the global head critical communications of another French company, NNSys Technologies. I've been involved in private networks now for up to 30 years, although we used to call them private mobile radio networks back then. So I've been a director and board member of the TETRA Association, now the Critical Communications Association, TCCA. And I'm very pleased to see my panelists, Bob here in the room, and a number of you remotely as well. What I would like, so we have Wendy from Obvious, who will deal with 3GPP standardization, Stan from Acceleron, who will looking, I'm guessing, more at the RAN, the radio access network, Nicolas from Athernet, who will be looking at developments within the core network, Bob here from LIFO, that will be talking about network optimization and maybe the use of multiple networks. And then Jeff from Atocore will be joining us to give us a roundup of perhaps some of the challenges faced within building private networks. So Wendy, I will hand the floor to you. Can you please very, very briefly introduce yourself, your organization, and then go into your presentation. Thank you very much.
Thank you very much, Peter. So my name is Wendy Ooms. I'm product manager at Obvious. And Obvious is a software vendor for private network solutions, focused on core, developed in France, and addressing the market through integrators. So why talk about standards? We at Obvious have chosen to participate in standardization to defend the interests of private networks. We are a member of ETSI and participate in 3GPP. And it's important to counterweigh the interest of public operators and vendors which are, from a historic perspective, present in 3GPP. So why standards are relevant? We talked about harmonization in the previous call. And I think it's obvious that there will always be a multi-vendor system. There's handsets, there's radio, there's core networks, and all these need to work together. And the only way to make that work together is to depend on standards. So the main standard organization for mobile networks is 3GPP, and it has proven its utility for public networks since 20, 30 years for now. So what has been done in standardization to facilitate enterprise networks or to facilitate private networks? There are some basic functions. And I think the importance I would like to stress today is, are they really useful? Are they really used for private networks? And I think that's an important question we should ask ourselves. So one of the first basic features that has been introduced is identification of the network. With a public network, every network is identified uniquely, and because of the range of numbers that has been used for that, there's a limit to the amount of numbers that is available. So what has been standardized in release 16 is an addition to those numbers to make sure that every network can be identified uniquely, so that you don't connect to a network that is not yours and that's not configured in your device. I think this is one of those features that can be useful, or that has been said it's important to have this. Either it's assigned by the regulator or it's self-assigned. But a question that we can pose ourselves, is this something that has been really used for now? So this is a feature that requires the support in the handsets, in the devices, in the radio, in the core network. And for this purpose, we need to see whether this is one of the functions that really enable private networks. A second functionality that is interesting that has been introduced is about neutral host solutions. I think later on in the day, when we talk about airports and ports, it's good. It's a solution to have multiple users or multiple enterprises using a shared network. I think this is some of the functionality that is very interesting for enterprises, especially to enable infrastructure in a shared area. I must say that from a standardization perspective, almost all 5G features also work with private networks. Maybe not as of the first releases, but as on the later releases of standardization, a lot of functionality has been added also for private networks, but a few things have not been standardized. And that's because of the politics, the ecosystem that works in the standardization organization. So one of the functionalities has not been standardized for private networks, has been roaming. Roaming between private networks and public networks. There has been an alternative model proposed, but the question is whether this alternative will be practically implemented, whether it will be supported in the handsets, in the chipsets, in the radio network, in the core networks. So the lack of roaming in the standard is because of the interest of public operators. They have been reluctant to standardize this. And that's why also our participation in standardization in order to defend the interest of private networks. So a lot of organizations, or there's more organizations that are participating in standardization in order to defend this interest. And I think I would like to stress today that that is important, that there are multiple parties present at standardization to counterweigh the public operators and vendors that are more looking at the public network. Another functionality I would like to point out that has not been standardized is interworking with EPC, with the 4G network. What I can say is that that doesn't mean that it cannot be implemented, but there's a risk that if it's not standardized and it's not supported in the standards, that not all the devices or not all the equipment that are used to implement private networks are supporting this functionality. Maybe to conclude, a few functions that I think are interested for enterprises which are not specifically related to private networks or the standards that have been made for private networks. Those are 5G LAN, so the possibility to have a local area network stretched over your 5G networks and to have a layer 2 VLAN. This is some of the functionality that we've implemented because I think it's important to have the local switching possibility in your network. The second one is framed routing. Imagine you have a router that is connected to your 5G network, and a device is connected to that router, so that you can have a whole networking behind your 5G system. So there's a subnet assigned to your 5G device, and behind that there are devices. Other points that are definitely not private network related only, but I think are very important to standardize also for the use in private networks, are satellite access and backhaul, mainly for the connectivity of connected bubbles or the mobile 5G solutions. And my colleague later in the afternoon in Roundtable 5 will talk about some use cases that can be used where you can use either satellite backhaul or something like satellite access can be interesting. The last point would be around positioning. Positioning in enterprises, where is your device located, is a very interesting feature. But the practicality of that we need to keep in mind. There's often a need to have, for example, very high-end radio devices with massive MIMO, a lot of antennas, in order to achieve this exact positioning, which for private networks is not so adapted, because there we're more aiming for less complicated small cells. But maybe Stan from Accelerant can comment on that point.
Thank you very much, Wendy. So I think, as you say, 3GPP traditionally has been dominated by a relatively small number of players. So what we've seen within 5G is this push towards a greater number of players, maybe the kind of SMEs and the and other kind of actors that will really. This will be a very, very important ecosystem to drive the private networks market. Hopefully we'll have time at the end for questions. I'll now pass over to Stan from Accelerant to continue the conversation.
Yes, thank you, Peter. So I am Stan Klaas. I am the CEO of Accelerant. Accelerant is a Belgium-based supplier of private 5G radio access network solutions. Our products, there's some echo here. Our products are designed to allow system integrators to deliver private 5G networks in a scalable way, and that's very important. When we look, coming down to the topic of the session, when we look at the latest developments in the enterprise-specific RAN solutions, it's important maybe to first look at what are the challenges that we have seen in deploying, which is essentially a technology that was designed for MNOs to deploy that in at an enterprise scale. So firstly, we observe the need for private networks to be fully integrated into the overarching management system of either system integrators, for those that are running it as a managed service, or into the operational network and management infrastructure of the end customer in case they are running the network themselves. To address this, we've developed a product that is designed with an API-first approach, ensuring full integration into the customer's operational network. We pride ourselves on being easy to integrate, and we have the track record to show that. Secondly, private networks are not only deployed in the frequency bands dedicated to private networks, but also are regularly deployed in frequency bands used traditionally by mobile operators. This introduces the need for a broad range of radio configurations, including power, MIMO setups, and different frequency bands, all of which must be supported. And all these combinations create a combinatory explosion that is hard to follow as an individual supplier. So to address this, we here at Accelerant, we're leveraging the open fronthaul interface, making radios easy to source from the large ecosystem of ORU suppliers. These ORUs can be easily and quickly integrated using the standard interfaces that have been defined for that. Thirdly, we see that every private network has its own unique set of requirements and challenges. And not all needs can be met with a one-size-fits-all solution. Therefore, we provide flexibility through our integrated RAN Intelligent Controller, making our product easy to adapt. This enables customers to automate and optimize the network as needed, with no dependencies to our own internal product development cycle. We offer an open and well-documented SDK, empowering our customers to take control of automation and optimization. As a last point, we see that a significant operational challenge is the consistent long-term maintenance of the product and service. To address this, we offer a state-of-the-art cloud-native vRAN solution that can be deployed using the well-known cloud technologies and ensures a consistent feature set across an ever-growing set of radio variants, both now and in the future. That makes our products both easy to deploy and maintain today and tomorrow. With that, I have said.
Yeah, okay. Thank you very much, Stan. You brought us back nicely onto time as well. Hopefully we'll have some time for questions towards the end. So now we will move from the radio access network to the core network to find out what another of our members, Athonet, is doing within the core. And for that, please, Nicolas, can you introduce yourself? And I'll be here moving the slides for you. So.
Thank you very much, Peter. Hello, everyone. Bonjour. My name is Nicola Di Pietro. I work for the Athonet Research and Innovation Department that is part of HPE. And indeed, I mean, I have prepared a few slides to address today's topic.
Yeah, it doesn't seem the slides don't appear to be moving, Nicolas. So I'm pressing. Yeah. This always happens. I tested it 10 times and it worked perfectly. And the first time live, I'm pressing and nothing happens. So we'll get the technical team to sort this out. Okay. Over to you, Nicolas.
Thank you very much. Also, I am not seeing the slides myself, so hopefully we can be synchronized enough.
You're on the title slide now, Nicolas, so maybe you introduce yourself.
No, I do. That's perfect. Yeah. So as I said, we can go to the next slide. I work for the Athonet Research and Innovation Department, and this slide briefly summarizes how this is related to HPE, right? So HPE, you may know the company, Hewlett-Packard Enterprise, is the global edge-to-cloud company. It's been operating since 2015 after the split of Hewlett-Packard in two companies, one of which is HPE, and the other one is still called HP Inc. You know it too for sure. We're a big company. We're more than 60,000 employees worldwide, and of course our portfolio covers a number of different technologies, among which telecommunications and mobile networks. And Athonet was acquired by HPE last year. Now we are fully part of HPE, and we focus, as this was introduced, on the core network and some end-to-end solutions for 4G and 5G private networks. We're also proud to say that at present, HPE Aruba Networking Enterprise Private 5G provides reliable wireless coverage across large campuses and industrial environments. And right now, HPE Aruba Networking is the only global enterprise infrastructure vendor that provides comprehensive Wi-Fi and private 5G solutions. And next slide, please. So I don't have to stress much at this point that it is becoming common practice for common businesses to have their own mobile network. We know this very well, and we know that the whole private network ecosystem, mobile network ecosystem, is moving from nationwide public networks to a plurality of small private customized networks that are applicable to a number of different verticals. I've put some here in the slide. They actually coincide with certain customers of ours, so it's really real networks we are talking about. And next slide, please. The points that I wanted, the points actually that I wanted to briefly stress today are the following. So in our view, the path towards fully embracing private networks, private 5G networks, and going beyond that goes through technological advancements. So keeping pushing the innovation at each specific component of the network, from the physical layer to the system layer. Then exploiting, even with creativity, the architectural pliancy introduced by 5G and fully embraced also by what's coming next, by the initial discussion on 6G. And then, of course, leverage the enhanced network management features that these kind of networks offer, especially compared to previous generations. And also I want to highlight that all of these fuels new business models and sometimes requires new business models to really be translated from pure research into actual technology. I will give in the next slides 3 examples about these points. So please, next slide. Thanks a lot. So this slide summarizes one example of what in 3GPP standard we would call standalone NPM. By the way, I'm happy because I prepared this slide before knowing that Stan would be speaking in the panel too. And it's the slide is about a project funded by the European Commission called 5G Timber. It's dedicated to the wood industry, as you can imagine. And for this project, we have deployed, together with Accelleron and other partners, a private network at Harmet, a modular wooden houses company in Estonia. And this is a clear example of how private networks can enhance the productivity and the operations and the business of industries. In this case, we have a standalone network, meaning that the whole infrastructure is deployed at the company's site and it is used for the private purposes of the company itself. In this specific case, private 5G is used to stream uplink videos from connected cameras to a central monitoring system and to enable a digital twinning use case, again, with a digital twin software provided by the Polytechnical University of Milan within the company's data center and gathering data through 5G from the shop floor. And then private 5G also is used in downlink to send, still please in the same slide, thanks, downlink to send alarms or to trigger messages to be sent to workers or to control devices, connected devices in the workflow too. Now, my point for this slide is not only to validate the fact that this kind of architecture is used, but also to highlight that some innovation still is required and certain novelties of 5G still needs to be fully embraced. For instance, part of this use case is based on positioning, that was also mentioned before by Wendy, but position technologies are not fully yet deployed in actual 5G networks. I want to highlight also the importance of O-RAN technology here, and the radio intelligent controller typical of O-RAN is used here because of its message bus, which is used to share information and alerts among all the applications and to trigger downlink alarms. Next slide, please. I was then talking about architectural pliancy. So we saw an example of a standalone deployment. It's on the right of the slide. We know that public networks typically fall in the all-cloud model, as named here, with all the core network in a cloud or centralized infrastructure, and then the radio, of course, close to the end users. But modern networks and private networks can, and even must, I would say, play with the flexibility of the architecture itself. We can bring the user plane, for instance, to the edge, or user plane plus other functions to the edge to build hybrid infrastructures and enable new, in the end, business models. We can have companies with multiple sites, all interconnected by the same, let's say, private network. And we can have people, devices moving from site to site and still find the same network, being able to access the same data network, for instance, with the same credentials and so on. This is actual, this works. And this, by the way, in another project, we exploited it even to bypass roaming, if you allow me to say so, in the sense that the same private network in two different countries, of course supported by internet connectivity in between sites, but was used, and devices could indeed be moved from site to site efficiently. Next slide, please. My third point and last point was about enhanced network management, and I want to introduce it by recalling the principles of the defining principles, if you want, of the 5G core network. We have the modularized and service-based architecture. We have user plane and control plane separation. We have network slicing to support heterogeneous services. And very importantly, we have novelties such as the capability of exposing control features to other entities out of the network. And then we have the capability of collecting and processing analytics from the network too. There are two functions in the core called NWDAF and NEF that are designed to do so. Next slide, please. And I'm mentioning here briefly a use case from another European project funded by the European Commission called Envelope, which is dedicated to the automotive sector and to automated mobility. And we have run some initial experiments in this situation. You can consider the simplified architecture here, in which we have a whole end-to-end system. It's, let's say, a big one, but it's still a private network. Could be a PNI-NPN, public network integrated non-public network, again, to adhere to standards, in which certain slices or certain resources of the network, of the public network, are reserved for private purposes. And in this network, we may have several different connected users, of course. We can have several slices, and then this possibility of exposing control features through NEF can be exploited by a third-party orchestration entity, let's say an orchestrator that acts as an application function, and this orchestrator can monitor how the network is performing, how connected users, what's the service perceived, the quality of experience, if you want, of connected users, and this, the application function can be used to tune, of course, if authorized, but we assume it is, to tune the network parameters to optimize this quality of service. Next slide, please. For instance, we can imagine that in order to perform some kind of load balancing, one slide back, two slides back now, in order to perform some load balancing, or for instance, to be sure that certain quality of service is, back again, please, Peters, to ensure that certain quality of service is guaranteed, so that, for instance, user plane functions are not saturated and so on and so forth, this application function can gather monitored data from the NWDAF through NEF and then leverage the exposed services of the NEF itself to shift traffic, for instance, for the red arrow from UPF1 to UPF2. And this is, let me highlight this, this is related to new business models in which an operator allows third parties to do so that these third parties can control the quality of service over their own private end-to-end services at an application level, right, at the service level, leveraging, though, the 5G infrastructure with a certain degree of independence. This is new, and this can be, let's be practical, this can be built. An operator can build a third-party service provider for the resources they use, a little bit as it happens in cloud computing, right? But now we're talking about networking, and the third-party external service provider has the interest of exploiting only as much resources as needed to guarantee the quality of service it is targeting, but not to overconsume, so not to overpay what they're using. Next slide, please. And in our little simulation results in the project that I'm talking about, we already showed that exploiting artificial intelligence and the capability of predicting traffic flows, indeed with these mechanisms, we can guarantee a 100% quality of service to the users, meaning that UPFs are never saturated and the needed throughput in the end is always guaranteed. We can increase then the efficiency of such a system. Of course, we are also exploiting automation capabilities in this sense to enable a closed control loop end to end, and reducing in the end only to strictly what needed, the exploitation of the second slice, again, motivated by the fact that the service provider doesn't want to pay too much. Final slide for me, it's the next one. To summarize the conclusion, private 5G is real, but we know that. We want to go beyond that. We need to leverage all our creativity and the flexibility of these new technologies to adapt to each use case and to innovate in the design of solutions for such use cases. And our point here is that beyond 5G solutions need to combine these different technologies from physical to system layer and to, in the end, finally transform into actual practice what 5G has been designing for now over a decade. Thank you very much. I hope I wasn't too long.
No, that's perfect, Nicola. Apologies for the person moving the slides as well.
No, that's fine. Thank you very much.
And welcome to Jeff there. That's good. So now everybody's on the screen. So I think flexibility is the important thing, Nicola, as well, because private networks, I mean, we used to have mobile networks that were very bulky, monolithic. And I think now we're seeing that as kind of more and more kind of software-defined networks, so even though there's a lot more complexity because of the number of functions, hopefully, as we move forward, we can actually make the operation of these networks simpler. I'll now pass over to Bob from LIFO. I've known LIFO now for a number of years. You have a very interesting, innovative solution, particularly when the one private network is not, maybe you require kind of additional functionality on top of your single private network. So over to you, Bob.
Thank you, Peter. So yes, I'm Bob. I work at sales at LIFO. LIFO is a Dutch company, has been in business for roughly 6 years now. And I just want to start with a little bit of history. I got to know the CEO, the CEO and founder of LIFO some probably 15 years ago, 15. And back then, it was a different company, of course, but they were focusing on delivering private 2G in the Netherlands. Believe it or not, it was already there in the Netherlands. And the reason there was private 2G was because people were suffering from poor coverage inside their buildings. And therefore, they had come up with this approach of delivering indoor coverage to deliver 2G to those premises. So it's been in their DNA from that time that connectivity, whatever cellular technology you're talking about, is an issue in some areas. Now, time has passed, and our industry has gone through a number of technological leaps. We've moved from 2G to 2.5G to 3G, 3G+. You name it, we're now at 5G.